Hi there, welcome to another vintage computer video. I've got the latest thing sitting here that I just couldn't say no to. This is a Rockwell AIM-65 computer. Right here, based on the 6502 CPU. Has a whole 4K of RAM in it, a 20 character display, a built-in printer, and about 20 kilobytes of ROM. So you can easily configure one of these to run Basic. You can configure it to run 4th, which is what's in there right now, or you can configure it to run PL65 or even a variant of Pascal. This one came in this nice looking industrial case. We're going to crack this open, look inside of it. I'm going to add a video display board so that we can get video output, and I'm going to add a speech synthesizer to make this thing talk, because the speech synthesizer is what I add to every vintage computer I get. So anyway, let's learn a little bit more about the Rockwell AIM-65. Okay, so I took the top off, I took the power supply out, and I set it over here so we can set it all out on the bench. Let's turn it on and see what happens. Enter date, month, day, and year. 2. How about 1985? I think it's locked up. 1, 2, 89. There we go. Now it's printed out a bunch of stuff. This is a computer plate by Repeat Corporation. All rights reserved, 1/2 of 1989. Job number, let's do job number 7. Pleat or pair or panel. 1. Size of overlap. 15 sounds good. Size of return. I don't know, how about 7? Width of goods. 25? Number of widths. 3. Just making all these up. I have no idea what this is. Finished width. 17. I printed out something, I could not tell what it was, and then it started over. So we're probably not giving it the right input. I do wonder, I'm assuming this is a basic program, so I wonder if I can control C it. Ah, look at there. There, I can actually print the program. Okay, let's take a look at this computer. So first let me pull this paper out of the way so we can see a little bit better. There we go. So we can see it's really a single board computer plus one board here for the display and another board up here for the keyboard. There's a bunch of RAM over here. These are 2114 RAM chips. And there's a bunch of ROMs here. The ROMs are R2332s. Those are this one, and this one. And then there's these two EEPROMs, which are 2532s. So I believe what we have here is we have the monitor sitting here in these two ROMs. We have the basic interpreter in these two. And then we have some custom software here in this one. Then we've got some peripheral chips. So the 6522. The 6502, that's the CPU. Under here is another 6522. And then here is a 6532 that handles the keyboard. We've got the thermal printer. There's a couple connectors that go out the back. This one here is for expansion, and this one here is for application. I believe this application connector is hooked to one of the 6522s. And then power comes in over here. It just has a connector, comes up here, hooks up to the power supply. Now there were some jacks that went out the back here for cassette and video. They were never hooked up to something, so the cassette ones over here could be hooked up to the application connector. The video is going to have to hook to a separate board that would have video on it. And then there's an HPIB connector over here, which was just never hooked to anything. There was nothing soldered to it. Couple switches up in the front. There's a reset switch. There's a run or step switch, and then there's a keyboard TTY switch. So there is actually a TTY that comes out the back, so we should be able to hook serial up to this if we want to. Okay, so I removed the proprietary program, which was in this DROM that had the compute complete program. And then I also reprogrammed this EROM here, which was the monitor. It had a jump in it that automatically called the application ROM. So what we have installed here are the 2 monitor ROMs and the 2 basic ROMs. So we should be able to boot this thing right into BASIC and run a BASIC program. Okay, let me go ahead and power it up. And it did its quick thing, printing out Rockwell AIM-65, which is over here on the printer as well. Now when it starts up, it automatically goes into the machine language monitor. So we can examine memory like M. Let's do B000. And you can see in here we're looking at the basic ROM. So you can go in here, you can look at the various stuff that's in there. Yeah, it's your typical machine language monitor. We should be able to change variables. Let me go down into lower memory. If we could do M, and then let's do like 0400. And so if we hit slash, we could change something. 1, 2, 3, 4, 5, 6. Now if we M0400. Yeah, so your typical machine language monitor. Now, if we hit the 5 key, it should go into BASIC. And it asks us for a memory size. Let's give it 2,000 bytes. And let's tell it it's 40 characters wide. So here we are inside of BASIC. And we could write a simple BASIC program. There, and I could run it. And here, let's put a loop in there. Here, we can list our program. And that's all coming out here on the paper as well. And let's go ahead and run it. All right. And there is, there's our program, and there's all the Scott was here's that are printed. Now, if the constant printing becomes annoying, you can actually hit Control Print, turns the printer off. Now, if we do a list, it just goes out the screen, which, it kind of went by fast, you couldn't see it. But later on, we will add a display board, and you'll be able to interact with it a little bit better. Now, what I'm going to do next is I'm going to pull out the basic ROMs. I'm going to install some 4th ROMs down here. Give that a shot. Okay, so these 4th ROMs, I burned those myself. I used 2532 EPROMs. And we should be able to boot into 4th now. So let's boot up. Now when we hit 5, yeah, there were an AIM 4th 1.3. Now 4th, if you've been watching my videos, is a really cool language that I like to play with. We'll tell it to print Scott, and it does Scott and OK. I'm not going to go through a whole lot about the 4th language here, but you can define your own words. So colon, new word called Scott. Let's print was here. And we'll add a carriage return and then semicolon to end the definition. Whoops, did I do it wrong? Let me try that again. Okay, we'd find the word Scott. So if I do Scott, and it prints out Scott was here in a carriage return. So we could define a new word to Scott. And I can do Scott. Semicolon. Now this one will run the Scott word twice, which should print Scott was here twice. Now let me demo one other ROM, which is this memory test. This one we replace the monitor. So let me go in here, I'll pull the monitor IC out. Now this memory test ROM is by Glitchworks, and when When this thing starts up, it'll actually test the memory, it'll test the riot chip, it'll test a bunch of stuff. So let me turn it on. So ROM checksum, stack page, 0 page. There's the riot RAM. And there it's checking the memory that's on board. So this memory test ROM, like I say, it's made by Glitchworks, and if you go to their GitHub, you can find the source code for it, you can build it, you can burn it yourself, and memory test your AIM-65. So this is really cool. Okay, another thing that we can do is it has this little switch here that's keyboard or TTY. There's a connector on the back here that you can use to connect a serial port to it. So I have made myself a little breakout, a little connector here. Max 202 driver, DB25. So we will hook that up there and we'll see if we can get a serial console. And that will be, you know, a little bit more convenient way of using the computer than interacting through the 20 character display. To use the TTY, you're supposed to be able to just flip the switch and then hit the del key on your computer a couple times, but I was not able to get that to work. So I have been using a mechanism that you can manually set the baud rate. So what we do, MA417, and then you have to actually enter the baud rate constants into memory, which are 01 and 5D. Now we can flip, switch to TTY. I'll just hit any key and it has switched to TTY. So let me move this over and we can look at my laptop now and see what is on the laptop. Okay, so here we are in my laptop, and it's just going to mirror the screen that would have been on the computers now here on the terminal. So, you know, if we hit something here like, well, we have to, only understands uppercase, so let's hit an M and B000. And just like before, you know, you can see memory. We can hit 5, and we're back in AIM 4th. So, oops, I don't have backspace working, so let's, yeah, we kind of botched that one, but let's go there. Scott was here. Carriage return. And we didn't need the semicolon, but anyway. Here, let me do it right. Let me define a word. Colon. Scott. Scott was here. Carriage return. Semicolon. Look, I can actually do a list of all the words that are in the 4th interpreter, and it'll print them all out there so you can see the ones I defined up there, and it is spewing out all of the other ones. So this is pretty cool. You know, this makes this into a fairly usable computer, having the terminal capability out, the RS-232. But we can do even better. We can build a display board and build display capability directly into the computer. And I'm going to do that next. Okay, now let's talk about building a display controller for this. So Rockwell actually produced a display board for their RM-65. Now the RM-65 was kind of a modular version of the AIM-65, but via an adapter board you could connect the RM-65 boards up to your AIM-65. And that's what people did. And this here is Rockwell's CRTC board. And this is on Hans Otten's site, where he has a lot of information. And, you know, it talks a little bit about here about how to build the board. And the character said, it doesn't have the schematic, but I was able to talk to Hugo Holden, who managed to reproduce this board. And Hugo has an article up on his website, and you can go there and read all about how he reproduced it. And he reproduced it by, a friend of his produced an X-ray of the board. So there's actually a picture of an X-ray, and he reproduced the 4-layer board exactly, and you can see the board he produced. And Hugo had copies of the schematic. I don't know if they're in his article here, but he had copies of the schematic he gave me, and I was able to reproduce the board myself as well. So, now we've got several different variants of it. There's Rockwell's original, there's Hugo's reproduction, as well as mine. And I took a little bit different approach with it. My approach here is all up on my website. And I wanted it to overlay on top of the AIM-65 rather than being put in a separate card cage. So I eliminated a few of the parts, and I went with a few programmable logic devices. And my schematic is actually up there, as well as the Gerbers and everything else. I'm not going to go through the schematic because, it'll take a little while to do that. You can actually find the original Rockwell sources. It's actually 2 pages long, a couple of programmable logic devices, and I did a few other things that I think will be helpful. One of the things I've done is to add a much larger ROM chip that replaces all of the ROMs on the main board. And let's see, it's over here. This here with some dip switches to select which bank of the ROM you want. With my ROM on the display board, you can actually have several different ROM sets that you can load into the AIM-65. And we'll see that when I go to demo it, how I'm able to switch between basic and fourth by flipping a dip switch. I also put an additional RAM chip on here so that we could backfill the main RAM beyond the original 4K that's there. So this is both, the board you'll see is both less complex than the Rockwell board due to my use of the PLDs, as well as having some more features, the additional ROM and the additional RAM. And with that, let's go ahead and get display capability on our AIM-65. Okay, here is the display board. So the big chip is, of course, the 6545 CRTC. And that is the display controller. It has the character generator ROM sitting over here, which is 2732. And then over here we have the video RAM, which is a 6116. Now, I've also got a ROM here to hold the program. This is actually a 39SF040, which is a nice big flash chip that I can program on my computer. And I can put several different complete ROM sets in this and switch them with this selector switch here. So rather than pulling ROMs in and out of the computer, I'll just put several different programming languages. I'll put my basic, I'll put my fourth, my diagnostic program, put it all on there and just flip between them with those dip switches. And then I've also added a RAM chip. This is a 62-256, and we'll use this to backfill the remaining memory space on the computer all the way up to 7FFF. And that will give this computer a full 32K of RAM. We've got a crystal here for the timing on it. The buffer chips, those couple of PLDs that I got, the video output jack, the video level is there. So to use this, I've designed it so it will piggyback on top of the AIM-65. So the motherboard will go beneath it. To do that, I've made this little back plane. So it's going to hook up like that. And then we can just layer it on top. So let's go ahead and do that. Okay, so in preparation for this, I have removed all of the ROMs. Because my new ROM chip here is going to have all of that in it already. I have left all the RAM chips in there, so we still have the 4 kilobytes of memory down here. We need to add the backplane connector. Then we need to take and plug in display board. And I have been putting, for peace of mind, a little spacer underneath here. So it is not, so the pins coming out of the bottom of this board are not sitting directly on any of the chips down there. Make sure nothing shorts out. So I've got it all plugged together. We can take my composite cable from my monitor, plug it in here. Okay, the monitor's on. Let's turn it on, and we should be good to go here. Now you notice it's not using the monitor yet. First, we have to actually start the video routine. So we do that by hitting star. This sets the program counter. We want to jump to 9900. So the program counter is set, and then I'm going to hit go. And there we go. It has now initialized the display screen. So now we're talking composite to my flat panel monitor. So again, I can do something like MB000. Now we can turn, we don't need the printer running the whole time, so we can turn the printer off. So yeah, just like you were using, you know, the TTY, or like you were using the screen, we're now using the video up here. So we can hit 5. I've switched it back to basic. Now we've got plenty of RAM, so I can hit like 30,000. And let's hit like 70 characters wide. We've got a wide display now. There, so here we are. Now this thing is really pretty usable. So let's do our short program again. Let's do 10 for I equals 1 to 10. Print Scott was here using his AIM-65 computer. Might as well print a long line since we've got plenty of screen real estate. 30, next I, and then list. There it is. There's our program. Run our program. All right. So like I said, pretty usable computer at this point. And the nice thing about this display is it seems to work with most of the programming languages and such. So here, let me turn the computer off. I'll switch over to 4th. There, we're on 4th now. Turn it back on. We've got to do our star 9900 again. And this time I can go into 4th. And here we are in 4th. Let's turn the printer off. Yep, working as it should. Let's do a V-list. Next up, let's do a speech synthesizer. So I always do a speech synthesizer. It's a nice simple schematic, fits on one sheet. So let's zoom in a little bit over here. Over here we have the bus from the AIM-65. So I've represented it as this package here. The bus has a bunch of address lines, not surprising, and some data lines, also not surprising. There's a reset, there's some interrupts, there's this O2, which is the clock, and down here there's a read slash write. It's active high is read, active low is write. So I took the data bus and I ran it through a buffer just to be a good citizen on the bus. I don't know how much my speech synthesizer chip might pull down, so run that through a buffer. And then down here I have an address decoder implemented in a PLD. So it takes all of the address lines and it takes the read-write line, the O2 line, some more address lines over there. I didn't decode all of the address lines. I kind of ran short on pins, so I only decoded down to about A3. So we'll use, you know, we'll waste about eight address spaces here for this. Out of this comes a line over here to enable that bus buffer. There are the address load, standby, and load requests. Those go to the speech chip. 2 of those are inputs. And then you might notice I've hooked my PLD up to D0. That's used for my implementation of polling to the speech synthesizer. So if you read an address, what I will do is I will hook the D0 bit up to the load request, and you'll be able to see that the load request in the speech synthesizer is waiting for a phoneme. And that takes us over to our speech synthesizer chip, which is the ever popular SPO256A-AL2, popular chip that Radio Shack used to sell. So it has 8 bits that come in here for telling which phoneme to say, some lines here for controlling it. The standby and load request are status bits. LRQ will go low when it wants you to add a phoneme. ALD is the strobe to strobe a phoneme into the speech synthesizer. You have a clock. It needs 3.12 megahertz clock. It needs a reset to reset the chip. Then you've got speech output. Now my speech output circuit I've used for a lot of my boards. It's over here. And it uses an op amp to do some filtering. I find that's a little cleaner than just doing the filtering without the op amp. So you've got some op amp, speech comes in, it goes through some low and high pass filters, comes out to a line level audio port, as well as going out here to the ever popular LM386 audio amplifier where we can go out a jack to a speaker. Okay, here is the speech synthesizer board. So fairly simple board. We have the SPO256 speech synthesizer chip there. We have an op amp here, and we have the LM386 audio amplifier there. There's a buffer here for the data lines, and there is the PLD that handles the addressing details. Over here we've got a couple outputs. This one here is amplified, and this one is line level. Now you notice I ran into a few issues here where I kind of didn't have room. I forgot that the 3.12 megahertz crystals I have are the tall ones, and I didn't really want a tall one in there, so I've kind of shoved it over to the side and folded the leads over to make it kind of fit on the board so it's nice and flat. Same thing with this capacitor here, kind of bent it over so that the board is nice and flat because we're going to pack it in with the other boards. And for the back plane, because I want to use both my display board and the sound board at the same time, I came up with this backplane adapter. We've got two sockets here relatively close together. We'll plug the AIM-65 into here, the display board on top just as before, and then I've got a little bit more room down here at the bottom where we can plug in the speech board. So let's give this a shot. Okay, so I have my computer hooked up here, my laptop hooked up to the TTY because I'm going to cut and paste a program into here. It'll be the easiest way to enter a long forth program to do the speech synthesizer. So let's go, we'll set up the TTY again. So we'll do MA417 015D, switch over to TTY. And now we'll go into fourth. Now this program I'm going to use is based on the Big Mouth speech synthesizer from the Jupiter Ace, and I happen to have that program ready because it's written in fourth. I did a speech synthesizer project with it in the Jupiter Ace, so it's a great place to base this one on. So we're just going to transfer it up here. So we're just gonna upload that program. Okay, so the program has uploaded. Now, down here at the bottom I've defined 3/4 words that will speak various phrases. Because this originally came from the Big Mouth for the Jupiter Ace, so I left this first one in here, which says I am the Jupiter Ace computer. Of course this is not a Jupiter Ace, so I have another one here that says I am a Rockwell AIM-65. Then I have Scott was here. Now each one of these words, it simply defines itself as calling all of the individual phonemes. So for example, Scott was here is the SSKK1AATT, Scott, and then was here. So anyway, let's have it talk.
I am the Jupiter Ace computer.
We'll do it twice just for good recording.
I am the Jupiter Ace computer.
Now, to make a little bit more sense, let's say I am the Rockwell AIM-65.
I am the Rockwell AIM-65 computer. I am the Rockwell AIM-65 computer.
And then finally, Scott was here.
Scott was here. Scott was here.
Okay, and there you have it, a speech synthesizer for the Rockwell AIM-65. Okay, I hope you enjoyed this video on the Rockwell AIM-65. If you used an AIM-65 back in the day, please drop me a comment and let me know what you did with it. Also, please subscribe to the channel, please tell your friends. And if you have any peripherals you would like to see me build for an AIM-65, let me know and I'll see what I can do. Thank you. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.